All right, so I'm recording. So if you don't want your voice to be heard by everybody else, you can type in the chat and I can see what you're saying, and I'll address any questions you have. And if you're comfortable talking, that's fine. So first, some policy stuff. The test is going to work the exact same as test one. Even down to the number of questions, I guess. I was trying to make, attempted to, and I tried to make it fewer questions this time, but then my boss said, no, keep it the same number of questions. So it looks like even down to the number of questions for like multiple choice and free response is going to be the same. But as I said in my announcement earlier in the week, I think this group of like these four sections are kind of the easiest sections of the course. So I don't anticipate too many time problems for people. I think the test is going to go pretty smoothly and pretty quickly for you guys. So I think if any of you guys had problems on time on the first test, I think this test will be better. And the questions, I've also kind of played with the difficulty of the questions a little bit, and I think the questions I wrote this time are on average a bit easier than the first test. Okay, but let's say same number questions for everything. Okay, multiple choice and the free response stuff, and then the submission works the exact same way. So just like you did on the first test, you'll answer, four or five of the multiple choice questions directly on web courses, and then you'll write out your free response answers on paper, separate pages for each problem, combine them all into a single PDF, upload them. Same time window. It's going to be during our normal, our class time that's on the books, like 10:30 to 11:50. That's going to be the test window. And I'll give a little bit of padding for people who start late and things like that. So if you start within 10 minutes or so, you'll still get the full amount of time, and so on. So any questions on test policy before we go on to content? Okay, it doesn't seem like any questions on the test policy. So as far as content goes, I'm not gonna, this is gonna be a similar review to last time, where I'll kind of just lay out what I think you guys should know from each section first, and then at the end, we can go over specific problems if you like. So first, for section 7.8, okay, this is the improper integrals. As I said in the announcement for the quiz for last week, the quiz that's due tonight, notation is really important for this section. Okay, so when we have a integral that goes, from 0 to infinity, okay, it's crucial that that first step is rewriting as a limit. Okay. So if it's type 1 improper integral, which is like when we have infinity in the bounds, okay, we need to write that as limit as t goes to infinity of the integral. Okay, and then the subsequent steps follow. Okay, I'm not going to go through every step. So just know how to do, let's see, this is a like kind of standard type 1 integral, right? Where we just have from 0 to infinity. So in this case, we only have like one bound. That's a problem. We're just having a problem with this one infinity. We also need to be able to deal with the case where we have infinity in both bounds. So maybe we have infinity or negative infinity to infinity. Okay. So remember how to deal with that. We have to split this up into two limits. And then we need to do our process for each one of these pieces. Okay. So you need to know how to do the standard kind of type 1 and then the type 1 where we have infinity in both bounds. Okay. And then for type 2, we have similar stuff. Remember, type 2 is when we have discontinuity, okay, where like our function maybe goes up to infinity. So like 1 over x dx, for example, 0 to 5. Okay, so I don't have infinity in either one of these, but this lower bound, what's happening at this lower bound, I have a discontinuity for this function here. So my function is going to go up to infinity at that point 0. So I need to handle this in the same way I handle my infinities. I need to turn that into a limit. And this time, the thing I'm replacing with t is my discontinuity. Okay. So I need to be able to, this is kind of the standard type 2 where we just have one discontinuity right there at one of the endpoints. And then we also need to be able to handle the case where, what if the discontinuity is kind of in the middle of these bounds, okay? So we need to be able to handle this as well. So the discontinuity, this is discontinuous at 0, right? So that's like right in between -1 and 1. So again, I need to split that up into two pieces. I need to split that up into, let's see, say t approaches 0. Okay, so that would be how you would split this problem up. So we got to be able to do kind of two types for each of, or two problems for each of these types, right? Like type 1, okay, maybe I have 0 to infinity, or maybe I have -infinity to infinity. And for this type 2 stuff, okay, maybe I have a discontinuity at one of my endpoints, or maybe it's right in the middle. Okay. So that kind of covers all of the cases I want you guys to be aware of. Since there's not much material for the test, like 4 sections isn't much to test on, so expect to see maybe multiple questions for each section. So you might see like a couple of these forms on the test. You might have like, you probably won't get all 4, but maybe like there's kind of like 4 different things I went over here. You might get like 2 out of those 4. Okay, so you should, I'm not going to tell you which ones you're going to get, so you should be able to do all 4 of these things, right? As far as the rest of this section, I'll kind of grade your quizzes and see how you did tonight. The deadline's tonight, so I'll give you feedback on those quizzes. You should get that back by tomorrow. So check in on how you did on that quiz tomorrow, and then if you have questions, we can talk about it in office hours tomorrow. I'll move on to 8.1 now, and at this point, if there's any questions on 7.8, feel free to chime in or type in the chat. Okay, moving on to 8.1. I feel like 8.1 is fairly straightforward. I don't want to say easy because everybody has a different idea of what's easy and what's not. But I don't think there's too many places to get confused in 8.1. We have a curve y equals f of x between some points, between x equals a and x equals b. I want to find the arc length of this curve. It's just a simple formula, a to b, 1 plus f prime of x, and I need to make sure to square this f prime of x. Okay. So simple formula, expect, at least one or two problems on arc length. I probably won't ask you, like, I'll probably keep it y as a function of x. I think in your homeworks, maybe some of you maybe sometimes you had x as a function of y and you had to find that arc length. I think I'm going to stick to this standard format, y equals function of x. So don't worry about this if that kind of confuses you. So again, pretty straightforward. Any questions on arc length? All right, 10-1. So the half the material from the test is going to be coming from this 10-1, 10-2. So it might feel like it's being kind of heavily represented. I think it comes out to about half, but I don't know. Maybe you guys will feel differently. For 10-1, let's see, what is 10-1? We got to know how to. We need to be able to graph parametric curves. We need to be able to graph. We need to be able to eliminate the parameter to write as a Cartesian equation. One thing I'll say about this, eliminating the parameter, right? There was a lot of times there was a choice on how to do this, right? We could solve for t in x, right? We could solve for t in this equation and get a value for t and then plug that into this equation, and we would end up with y equals like, some function of x. Or we could have done it the other way, right? We could have solved for t in this equation and then plugged it into this, and we would have ended up with like x equals, some function of y. Okay. So maybe on the multiple choice, I picked one answer in particular. Okay. So if you're solving these multiple choice problems and you feel like you've done the eliminating the parameter correctly, but you don't see the answer, maybe it's because you solved for this equation, but I solved for this equation. Okay. So these problems, the problems I wrote for this, I've written the tests already, so I kind of can speak on this with, some reliability, that these problems I wrote aren't problems that are going to take like it takes 20 minutes to solve it one way and then your answer's not there and you got to spend another 20 minutes. No, it's stuff that can be done fairly quickly. So if you don't see your answer when you solve for t in this equation, okay, maybe try solving for t in this other one to see if your answer is there if you solve it that way. Okay. And that's really all the material from 10-1. I think 10-1 is really just focused on graphing and eliminating the parameter. So if you can do those two things reliably, you should be good on those problems. Any questions on 10-1? Okay, if no other questions, 10-2. So 10-2 is when we start doing, this stuff's not really calculus, right? It's just kind of graphing and some algebra, really. So 10-2 is kind of when we get back into doing calculus, derivatives, really. So all what you need to do is, let's see, what you need to know is you need to be able to find dy dx. You need to be able to find d squared y over dx squared, and then the rest of these two things were really the main points of 10-2. If you watched my lecture, I kind of said like everything else is just kind of applications of these derivatives, right? So when you had problems about, maybe you had a parametric curve and you had to find the equation of the tangent line at that point, right? Well, that was really just about finding the derivative. You find the derivative that gives you the slope of this line, and then the rest is just algebra, finding the equation of the line through that point with this particular slope, okay? So, and then the application for like the second derivative was the problems like concavity, right? So we find the second derivative, and then we try and figure out where it's positive, where it's negative, and when it's going to be when it's positive, our graph's going to be concave up. When it's negative, it's going to be concave down. Okay, so really, the heavy math is just being able to find these derivatives, and then the other stuff is just kind of accessories to that. All right, so I would know how to find these equations of these tangent lines, and I would be able to do, I would say knowing how to do the concavity problems is a good place to start as well. The concavity stuff, I'm not going to give you anything super crazy where you end up with something, some crazy inequality at the end, like uh, I'm just trying to think of something super complicated. I'm not going to give you anything where it's like trying to solve super hard inequality. At the end for concavity, maybe you'll end up with a second derivative. It'll be fairly straightforward. Maybe t to the fourth plus 1 over negative t squared. And you need to be able to tell, let's say this is my second derivative. You need to be able to look at this and say, okay, when is this positive and when is it negative? Okay, that's going to tell you about your concavity, right? So this is kind of maybe the level of that concavity stuff we need to be able to do. Okay, solving for when this is greater than 0. Any questions on what I've just said? All right. As far as and that's kind of where the test ends, right? So this is I've kind of pointed out the stuff I wanted to point out to you. As far as far as review, that's really all I had in mind. Not much of a review, more of like a kind of pointers. And let's see, somebody asked, can we work through a concavity problem? Absolutely. All right, and that's kind of what I was about to say. Now's the time to give me problems you want to see worked out. So let's pick a concavity problem. I'll go to the textbook here. Okay. So let's start with the system of parametric equations. And just a side note, I think I've put out problem videos for most of the sections. I think 10.2 I need, so this material still needs a problem video. So I'll do that either tonight or tomorrow. So I want to give you guys at least a couple days with it before the test. And hopefully, that'll help. I apologize for not getting it out sooner, but I got my own things going on. But yeah, so expect a problem video on 10.2 for some more problems of this nature. But let's work on this one. So first, if I'm asked to find where my, so the problem says, okay, where's the curve concave upward? Okay. So how do I begin to solve this problem? First, I need to find, to solve this problem, I need to find the second derivative. And I should find d2y over dx squared. Okay, so I need to find this. And then it's going to be my curve is going to be concave upward where this thing's positive. All right. But first step, finding second derivative. All right. So how do I find the second derivative? Well, first I need to find the first derivative. I need to find this first. Right? I need to find dy dx. From my formula for parametric stuff, I know this is going to be dy dt over dx dt. Okay, so let's find these things. Why is this? So dy dt is equal to 2t plus 1. Dx dt, okay, what's the derivative of this with respect to t? It's just 2t. Okay. So dy dx is going to be 2t plus 1 over 2t. And I can simplify this, and it's going to really make your life simpler to sit at this stage, simplify as much as possible. That's going to make finding the second derivative easier. Okay. So for instance, if I left my derivative like this, the next step for finding the second derivative, right, would I differentiate this thing with respect to t. Okay. So if I differentiate this thing as it is with respect to t, that's going to involve quotient rule, right? It would be, let's see, it would be 2t times 2 minus 2t plus 1 times 2 all over 2t squared, right? Okay, that's derivative of this with respect to t using quotient rule. Okay, so kind of complicated. It's going to be a lot simpler if I simplify this thing first. Okay, so let's simplify this. This thing is equal to what? 1 plus 1 over 2t. Okay, and then I just take the derivative of this. All right, what's the derivative of this with respect to t? Well, that would be, this, I could rewrite this as this, and then derivative of this would be just negative 2t to the negative 2 times 2. Okay, so maybe a bit easier solving it that way by, first simplifying to this and then taking the derivative of that. But we still haven't found the second derivative, right? This is our process is we had dy dx, okay? Then we differentiated with respect to t, and then we need to divide by dx dt again, okay? Okay, so all we've done is found this numerator. Okay, so the numerator we have is negative 2 over 2t squared, and then I need to divide by dx dt again. And I already found dx dt, right? We said that was 2t. Okay, so my second derivative of this is my full form of my second derivative. Okay, so let's go ahead and simplify. It just simplifies as this. Okay, now for concavity, the question is, all right, where is this positive? Where is it negative? Okay, so let's think about it like this. When is this greater than 0? When is it less than 0? Okay, before we even put a I'll kind of give you, there's a formal way to do this and a kind of informal way to do this. The informal way, which I like a lot, is just say, okay, when I have a fraction, when is it positive? It's going to be positive when I have like positive over positive or negative over negative, right? So I can ask, okay, what's going on with this fraction? Okay, well, this numerator is always negative, right? It's just negative 2 on top. So that numerator is always negative. All right, so the only way that this fraction can be positive is if this denominator is negative. So when is that denominator negative? Well, that's going to be negative when t is less than 0, right? Okay. So that means on this number line, okay, to the left of 0, my denominator is going to be negative, and so my entire second derivative is going to be positive. Okay, if this isn't making sense, I'll give a more methodical way to do this in a second. All right, and then On the other hand, when this denominator is positive, I'm going to have a negative number over a positive number. Okay, so for t greater than 0, my second derivative is going to be negative. Okay, so this is the positive and negative parts of my second derivative. So I can see my curve is going to be concave up for t less than 0, concave down for t greater than 0. All right, and for the test, I would accept these types of statements. On homeworks, it might want interval notation, right? So how do we write the interval t less than 0? That would just be negative infinity to 0. How do we write t greater than 0? That's just 0 to infinity. Okay. All right. So that's the kind of intuitive way to solve for concavity. All right. If that doesn't make sense to you, if you're not comfortable with that kind of thought process, there's a very methodical way to do this that I can show you now. Everything's the same up until this part, okay, up through this part. So we find the second derivative, okay? So you have to do that no matter which method you use. Let me erase all this stuff. Okay, so you find the second derivative. And now you got to figure out, all right, where's this positive, where's it negative? Okay, what's going on with its sign? So what you can do is you can draw the number line and then put all the points where the numerator is 0 or the denominator is 0 on the number line. Okay. So it's pretty clear that the numerator is never 0, right? It's always just -2. Okay, so I don't have to worry about anything coming from the numerator. When is the denominator 0? Well, it's only 0 when t is equal to 0. So the only point I have to worry about is right here at 0. Okay, so this is the only point where my sign can change. Okay, so I graph this point on my number line, and then all I do is I test each side of my number line. I'm going to pick a random number on, let's see, okay. I'm going to pick a random number in this left piece. Okay, so let's say I pick the number -1. I'm going to plug it in to my second derivative. Okay, when I plug in -1, what do I get? I get -2 over 2 times -1 to the power 3, which gives me -2 over -8. And that's a positive number, right? All right. So that means I've found that this point is positive, and all the other points in the same section are going to be the same sign. So I know everything to the left of 0 is going to be positive. Okay. Now let's test this negative section, or this right section. Okay. Just because this section is positive, that doesn't mean that this section is automatically going to be negative. Okay. We have to test them individually. So what do? I just pick some random point in this right piece here. Okay. So what would be a number in this right piece? I could pick 1. And now I'm going to plug that into my second derivative. Okay. So when I plug in +1, I get, let's see, -2 over 2 times 1 cubed equals -2 over 8. That's a negative number. Okay. And all the other points in the same section are going to have the same sign. So I know all these points are going to be negative. Okay. So now I've found the same information. My second derivative is going to be positive when t is less than 0. So in this left piece. And it's going to be negative in this right piece. So hopefully that helps. And as I said, I'll do a problem video for this section in the next couple days. Anybody else have more problems they want to go over, or more from this section? It's my apartment. Okay. No. I don't know if you guys want to hear a quick story. My wife and I have bought a house and we were planning to move out anyway, and we just hadn't started packing yet. And then we actually close on the 29th. So we're going to be moving out of here and into our new house on the 29th. But we were just kind of waiting around to move. And then this flood happened and our carpet got totally ruined. And people have had to come in here and rip out all the carpet and all that. But it's kind of been good because it's forced us to pack. We had to like pick all our stuff up to get it away from the water. So we just went ahead and packed everything. So it's like, all right, now all our stuff is packed, and the apartment's livable, but it's not very comfortable right now. But the good news is I'm moving out in a couple of weeks. But thank you for asking. Uh, any further questions about math or my personal life or anything like that? All right. Well, I'll hang around here for a couple minutes. And you guys, if you don't have anything further to talk about, you can start signing out. If you want to hang around and ask me a question when other people are around, that's fine. So I'll hang out for a couple minutes, and let me know if you need anything. Yeah, you're welcome. No problem. All right. I will shut it off there. Uh, Good luck on the test, and my office hour. I'll have more office hours tomorrow and Wednesday at the same time.